let's talk about hubs and switches. Before the switches, there were devices called hubs. The hub just retransmits the signal received from one port to all ports. Just for instance, if we take a hub, if one device is going to send information to another device, hub just receives this information and retransmits this information to all its ports. Let's assume that we have hub here, or we have 5 hubs here. Actually, the devices you see in the picture are switches. But let's assume that we have hubs here. We have 5 hubs here. We have computer. Computer 1 is connected to the first port of this hub, and we have computer 2 is connected to the second port of this hub. Computer 1 is going to send some information to computer 2. So it sends signal here in this port 1, and hub retransmits this signal to all ports in this hub. This type of signal is called broadcast signal. Broadcast means that it transmits, the signal is going to everywhere, to every device, to every port. And if we are going to take computer number 3, and computer number 2 is going to send some information to computer number 3, the same process happens again. Hub receives this information and transmits to all its ports again, until the computer connected to some port receives this information. And the same thing happens with this device. If this device is going to send the information back to computer 1, the same procedure happens again. That's how hub works. This device, this kind of system has some disadvantages. One of disadvantages is network latency. So as this hub doing much work, as for each request, in order to receive some information and receive some information from one port and send the information directly to the second port, hub doing a lot of additional work, unnecessary work. It sends broadcast signal to all its ports. In this case, the hub is always overloaded. The network is always overloaded, and hub is always overloaded, and we have a lot of problems with functionality. We have delays in network, we have delays everywhere. So it's not good. It's one of the disadvantages. The second disadvantage is security. Using hubs is not good from the security perspective, because as you can see, we have 5 devices here, and these devices is connected to each other. This device connected here, this device is connected here, and so on. This is here and this is here. They are connected together. And if we have one computer here, computer or any device, doesn't matter, it may be server, it may be IP phone, it may be network printer, and so on. For instance, we have computer number 4 here, and this computer number 1 wants to send some information to this computer, to computer number 4. The computer number 4 is connected to the switch, to some port on the switch, and as you guess, when this switch receives this information, this hub receives this information, it sends this information, broadcast signal, to all its ports. But of course, this computer number 4 is not connected to this hub. It's connected to this hub. So this hub sends information to all its ports, and even to this port, uplink port. These ports are called uplink connections or uplink ports. It means that uplink ports are used to connect one switch or one hub to another hub. So and these broadcast signals comes out of this port, uplink port as well. Second hub receives this broadcast and also sends information to all its ports. Third hub receives the information, also sent to all ports. This hub, and at last the final hub receives information, sends the signals to all its ports until this device connected to the 24th port or 23rd port receives this signal, receives this request sent from computer number 1. As you can see, by sending just one information from one computer to another computer, all 5 hubs are overloaded. All network is overloaded. And from security perspective, let's imagine that we have some evil person sitting somewhere here in the middle. We have some evil person, some hacker. He's connected to this hub, and he can see all the information computers send to each other, because this information going out from all the ports, and this person can catch this information and use this information. So it's not good. It's not good. And nowadays we don't use hubs anymore. We use smart devices, which is called switches. How switch work? Switch uses technology called bridge, and this technology, bridge technology, included in the chip, integrated in the chip, which is called ASIC chip. This ASIC chip is a chip which is placed on the motherboard of our switch. This chip is integrated in our switch. Okay, so switches use technology bridge, which is integrated into. Before this bridge technology was a software technology. Later, it became a hardware technology and has been integrated into the chip, microchip. It's called ASIC chip, which is located in the motherboard of our switch. So in this scenario, we have 5 switches here. Computer number 1 connected to this first port. Computer number 2 is connected to the second port of the switch. Computer number 1 tries to send some information to computer number 2. So for the first time, let's assume that we just unpacked our new switch and turned it on, or we just restarted our switch. Our switch doesn't have any information yet. For the first time, when our new computer trying to send information to computer number 2, switch doesn't know about computer number 2 or computer number 1. Switch doesn't know anything. For the first time, switch sends this information to all its ports. So switch sends broadcast signal for the first time, and as soon as the switch sends this broadcast signal, switch has a table called cam table. As soon as switch receives the request from computer 1, it puts information about computer 1 into its cam table. So it looks like computer number, port number, port number 1, IP address of computer, for instance, or MAC address and MAC address of a computer. So a switch puts this information into its cam table and keeps it for some period of time. Keeps it, and as soon as, after broadcast signal, as soon as the recipient device receives information from computer 1, switch also remembers the port where second device is connected and put all information about this device in this cam table also. For example, port number 2, IP address of device, and MAC address of the device. Now switch has information about these two devices. Next time this device, computer number 1 or computer number 2, doesn't matter, tries to connect to each other, switch doesn't send broadcast signals because switch already has this information. Switch already has information about these two devices in its CAM table, and for the next time switch just send unicast signal. Unicast means one from 1 to 1. So next time this device is going to send some information to this device, or this device number 2 trying to send information to this device, switch just retransmits this device using unicast signal from this port directly to this port, not using broadcast anymore. But there is a one little nuance. This CAM table keeps all the information maximum 5 minutes. So what does it mean? If during these 5 minutes, if within these 5 minutes, one of these devices which are already in the list, if during these 5 minutes there is no activity from one of these devices, so information about that device is deleting after 5 minutes. For example, if we have computer 3 over here and it's connected to the port 3, and switch switch got information about these three computers, port 3, IP address, etc. Switch knows information about all these 3 devices, and they connect to each other, sending information to each other, and so it's okay. But for example, these 2 devices, computer 1, computer 2, communicating with each other every minute. So signal which is going from one device to another device is unicast signal, always going here from one port, first port to the second port. This is a unicast signal. These devices interact with each other every minute, and it's okay. But this device connects or send request or receives, doesn't matter. This device have activity just once every 10 minutes, for example, once every 10 minutes. So what does it mean? For the first time, when some device is going to connect to this device, or this device is going to connect to other devices, for the first time, of course, switch sends broadcast signal. So for example, no, I didn't say right. For the first time, when some devices, device number 1 or device number 2, are going to connect to this device, switch sends broadcast signal, and as soon as this device accepts the information, switch puts its information to its CAM table, and it's okay. But if more than during 5 minutes this device doesn't have any activity, information about this device is deleting from the CAM table. And after 5 minutes, maybe after 10 minutes, 15 minutes, doesn't matter, any of these devices are going to send information to the device again. Switch doesn't have this information anymore because switch deleted, its time expired, and switch deleted information about this device from its CAM table. So switch sends broadcast signal again to all its ports until this device receives information. Switch puts information about this device to its CAM table again. It puts again, and again, if this device doesn't have activity during 5 minutes, and every information has been deleting again, and cycle begins again. So again, these devices send information, again broadcast, etc. But if these devices interact with each other, or these devices interact with each other every 4 minutes, at least every 4 minutes, or almost 5 minutes, before the information deleted from the CAM table. So switch doesn't send broadcast signal because switch already has information about all these devices on its CAM table, and switch just using unicast signals. So as you can see, switch is more better than hubs, and this is the main difference between switch and hub. Also, switches, there are two layers of switches: layer 2 switches and layer 3 switches. Layer 2 switches work with MAC addresses of devices. We'll go through OSI model with you in our future lessons. I'll explain deeply what layers mean and so on. Layer 2 switches working only with hardware, with MAC addresses of devices. Layer 3 switches working with IP addresses. They have options, some router options. These switches have some router options here. And of course, these switches are more expensive than layer 2 switches. That's it for now. Thanks for watching.